Greetings to all. Myself Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the multi-level queue scheduling and multi-level feedback queue scheduling in operating systems. First one, multi-level queue scheduling. The ready queue is partitioned into the separate queues. For example, we separate as foreground and the background one. In foreground we defined as an interactive one, and the background we defined as an batch one. Next point, partition the ready queue is into the several separate queues. That is, processes are permanently assigned to one queue based on some property of the process, such as memory size, process priority, or the process type. Next one, each queue has its own scheduling algorithm. That is, already we defined a foreground one and the background one. In foreground one, we defined as a round robin scheduling algorithm. In background, we defined as first come first serve scheduling algorithm. The scheduling must be done between the queues. The fixed priority scheduling, that is, serve all from the foreground, then from the background. Next one, possibility of the starvations, that is time slice. Each queue gets a certain amount of CPU time, but it can be scheduled among its process. That is, we defined as a time slice, that is 80% of the foreground in round robin and the remaining 20% to the background in FCFS, that is first come first serve scheduling algorithm. Here we have the diagrammatic representation. First, it starts from the higher priority and it goes to the lower priority. The higher priority start from the system process, followed by the interactive processes. Third one, interactive editing processes, and then batch processes, and then last one is student processes. This is the it's from higher priority to the lower priority. Next one, multi-level feedback queue scheduling. That is, the process can move between the various queues. That is, aging can be implemented this way. That is, multi-level feedback queue scheduler defined by the following parameters. Here we define the 5 parameters. We define any one of the parameter. That is, number of the queues, and second one is scheduling algorithm for each queue. Third one is method used to determine when to upgrade the process. Fourth parameter is method used to determine when to demote a process. Fifth one is method used to determine which queue or a process when the process needs a service. Here these are the 5 parameters in the multi-level feedback queue scheduler. Next one, here we have the example of the multi-level feedback queue. Here first box is the quantum that given as an 8 milliseconds. That is, here we define first box is q0. Next, after executing that q0, that is quantum time is equal to 8 milliseconds. After it executes, it goes on to the q1, that is quantum time is given as 16 milliseconds. After the execution of the quantum q1, that is quantum time 16 milliseconds, it goes to the FCFS, that is background one. Here first two, that is 80% as comes under the round robin, that is foreground one. Remaining 20% comes under the background, that is FCFS scheduling algorithm. Here we defined as 3 queues, that is q0, q1 and q2. Here q0, that is round robin with the time quantum 8 milliseconds, we defined as a q0, and then round robin time quantum with the 16 milliseconds we defined as the q1, and then the last one q2, that is FCFS, that is first come first serve. Next one is scheduling. A new job enters to the Q0, which is served as a FCFS, but we have to see that foreground, that is round robin algorithm. When it gains a CPU, the job receives the 8 milliseconds. If it does not finish in 8 milliseconds, job is moved to the QQ1. At the Q1, job is again served FCFS and receives the 16 additional milliseconds, and then if it is still does not complete, it is preempted and moved to the Q2. That is, after completing the Q1, it moved to the Q2, that is FCFS scheduling algorithm, that is it comes under the background one. Thank you.